Hello, welcome to my channel. In this video I'm going to be teaching you how to determine the LCM of a set of numbers. The LCM of a set of numbers is a number which is a multiple of one number in the set of numbers. Now if you don't understand that definition, maybe you understand after this example. If we have two numbers, 3 and 8. Now for this set of numbers, if we are asked to determine the LCM is going to be a number which is a multiple of 3 and also a multiple of 8. That's why the full meaning of LCM, it stands for lowest common multiple. Lowest common multiple is a number which is, or is the lowest number which is a multiple of both 3 and 8. Now to determine this, we can start by drawing a table. Have 3 and 8. So what we'll do now is to divide by the smallest number, which can divide at least one of these two numbers. Now 8 is an even number, which means it can be divided by 2. So first we are going to divide by 2. 8 divided by 2 is 4. And since 2 cannot divide 3, we just bring down the 3. Next, we divide by the smallest number. The smallest number in this case is also 2, since 4 is an even number. So if we divide 3 by 2, we're just going to bring down the 3 and divide 4 by 2. 4 divided by 2 is 2. And so we are going to keep dividing until 8 and 3 is divided to 1. Now 2 is also remaining here, so we divide by 2. Since 2 is the smallest number which can go, 3 divided by 2 will still bring down the 3 and we are left with 1, meaning we are done with this 8, with breaking down this 8, and we can now focus on 3. Now the smallest number that can divide in this case is 3. Since we have done with 8, we can leave the 3 and we can bring down 1 or 3. Oh, sorry. 3 divided by 3 is 1, and we also brought down 1 here, since 3 divided by 1 divided by 3 is going to be a decimal number, so we just bring it down. So now that we have both 3 and 8 broken down into 1, 1, we can now determine the LCM by multiplying all the prime numbers used in dividing. So therefore the LCM is equal to the product of everything on this left hand side, which is 2 times 2 times 2 times 3. And if we multiply this, 2 times 2 is 4 and 2 times 3 is 6, and 4 times 6 is 24. So therefore the LCM is 24. Therefore the LCM of 3 and 8 is 24. I note that these two numbers have 24 as its multiple. 8 times 8 times 3 is 24 and 3 times 8 is 24, meaning they both have 24 as its common multiple. So let's try more examples. Now what if we're asked to determine the LCM of 39, 15 and 26? Now how would you find the LCM of this set of numbers? Feel free to pause and try out this example. Now, like in the previous example, we are going to draw a table and next we are going to write down these figures in the table. I have 39, 15, 26. Now we're going to start dividing by the lowest prime number. The smallest prime number that can go into at least one of the three numbers is 2. Since 26 is an even number, 2 can divide 26. So if we write 2 here, 2 divided by, or 39 divided by 2 is a decimal number, so we'll just bring it down. We do the same for 15, since 15 is an odd number, and 26 divided by 2 is 13. Now there are no even numbers left in this case, so next we divide by the next prime number, which is 3. Now note, a prime number is a number that doesn't have any other factor except itself and 1. Examples of prime numbers are, we have 2, 3, 5, 7, 11, 13, 19, 23. All these and more are examples of prime numbers. And note, prime numbers are only divisible by itself and 1. They don't have any other number that can divide into it without a remainder, meaning without it being in a decimal or fractional form. So just take note of that. Now since we are dividing by 3, 39 divided by 3 is 13, and 15 divided by 3 is 5, and 13 divided by 3 is 13 can't be divided by 3, so we'll just bring down the 13. And since 13 is a prime number, meaning 3 cannot divide it, the only number that can divide 13 is 13 also. So next we are going to divide by the smallest number. The smallest prime number, which is next, is 5. So if we divide by 5 divided by 13, that won't work, so we just bring down 13. 5 divided by 5 is 1, and 13 divided by 5, we still do the same thing here. Now note, we have broken down this 15 and we are left with 1, so we can leave this part for now. Next we divide by the next prime number. The only prime number that can divide 13 is 13, so 13 is going to divide, and 13 divided by 13 is 1. You will have 1 here and you have 1, so therefore the LCM is equal to 2 times 3 times 5 times 13. And if you multiply all this together, you're going to have 390. So this is the LCM of 39, 15, and 26. Now if we have this set of numbers 24 and 78, I'll try to find the LCM of this set of numbers. So like in the previous example, we'll just draw a table. 24, 78, and next we are going to start dividing by the smallest prime number that can divide at least one. Now note, both numbers in this case are even numbers, so we are going to divide by 2. 24 divided by 2 is 12, and 78 divided by 2 is 39. And we are still going to divide by 2 since there is a number that is divisible by 2, which is 12. 12 divided by 2 is 6, and since this is not an even number, we'll just bring it down. 2 is going to divide 6 since 6 is an even number to give 3, and 2 can still divide 39, so we'll just bring that down. Now note, there are no even numbers left, so next we divide by the next prime number, which is 3. 3 divided by 3 is 1, and 39 divided by 3 is 13. And divide by the next prime number, which is 13. 13 here will bring down the 1, and 13 divided by 13 is 1. So therefore the LCM is equal to 2 times 2 times 2 times 3 times 13. And therefore the LCM is, if we multiply this, you have 312 as the answer. Now let's look at this set of numbers. If we have 8x and 4x, now try to find the LCM of these figures by yourself. Feel free to try out this example. So first we'll draw the table like we did in other examples. Draw a table here and write down the figures inside. 8x and 4x. So now we'll divide by the smallest number. Now note, 8x is equal to 8 times x, meaning if I were to divide by 2, 2 can divide 8 and it will give 4. So just take note of that. So we can divide by the smallest prime number, which is 2. 2 divided by 8x is 4x. So basically we are just treating the letters first. We first treat the letters, we first treat the numbers before we start treating the letters. 4x divided by 2 is 2x. Next we divide by 2 again, since we are left with even numbers. 2 divided by 4x is 2x. 4x divided by 2 is 2x, and 2x divided by 2 is x, or 1x. 1x and x, they are basically the same thing. Now we're going to keep dividing until we are left with the letters. Now we're going to divide by 2 again, and we'll be left with x here, and there also be an x here. So now we can treat the letters. Now we're going to divide by x. X divided by x is 1, and here too we're also going to have 1. So the LCM is equal to 2 times 2 times 2 times x. If you multiply these 3, you have 8, and 8 times x is 8x. So therefore the LCM is equal to 8x, and this is the LCM of 8x and 4x. Now let's say we have P, Q, and QR. This might be a little bit tricky. Okay, PQ square, and let's say QR square. Let's take it like this. Now also feel free to try and work this out on your own. Like the previous example, we're going to start by drawing a table. And write the figures inside. PQ square and QR square. Now we're going to start by dividing by the first letter. It doesn't really matter the letter that comes first when you're dividing, but let's just try to put it in alphabetical order. P comes first between these 3 letters. P, we have P, Q, R. P is the first letter in the, or P comes before Q and R in the alphabet, so I'm just choosing to divide by P first. Now if P divides, P will cancel out here, and you'll be left with Q squared, or 1Q squared. And since there is no P here, we just bring down QR squared. Next, we divide by the next letter. Since there are no more P's, we divide by Q. Q squared divided by 2. Oh, sorry, divided by Q. Now Q squared is Q times Q. And if we divide by Q, one of the Q's will cancel out and be left with only Q. Since this cancel out, you'll be left with 1, and 1 times Q is just Q, or 1Q. That is what is going to happen here. So we'll be left with Q, and here we'll be left with R squared, since Q also cancel out here. And now we are still going to divide by Q, since there is a Q remaining. Q divided by Q is 1, and we'll bring down the R squared. Now we're going to divide by R. R here we're going to bring down the 1, and here we're going to have R. R squared divided by R is R, and divided by R again we'll have 1 and 1. So therefore the LCM is equal to P times Q times Q times R times R. Q times Q is Q squared, R times R is R squared, and we have P. So P times Q squared times R squared is going to give us P Q squared R squared as the LCM of what we have here. Now if we have 9bc squared and 6bc squared, so 6bc squared, sorry, it's supposed to be 9b squared c, b squared c and 6bc squared. I'll try to find the LCM of these two figures by yourself. Feel free to try it out. So first, like always, we draw the table and write the figures inside. 9b squared c and 6bc squared. And now, since there are letters and numbers involved, we are going to divide by the smallest prime number, which is 2. Since 6 is an even number, we'll divide by 2. If we divide by 2 here, none of these digits here are divisible by 2, so we bring it down. 9b squared c, and here we'll have 3bc squared. And next, since there are no more even numbers, I'll divide by the next prime number, which is 3. 9b squared c divided by 3 is 3b squared c. And if I divide by 3 here, I'll have bc squared. Next, I'll divide by 3 again, and I'll have b squared c as the remaining figures, and I'll bring down bc squared here. Next, since I choose to divide the letters in alphabetical order, I'll divide by b first. So if I divide by b here, I'll have bc, and if I divide here, I'll be left with c squared, and I'll divide by b again here, and I'll be left with c here, and also c squared is going to come down. Next, I'm going to divide by c. C divided by c is 1, and c divided by c squared is c. And I'll divide by c again, and I'll be left with 1 and 1. So therefore, the LCM is the product of everything we have here. 2 times 3 times 3 is 18. So the LCM is equal to 2 times 3 times 3 times b times b times c times c. Two times 3 is 6, and 6 times 3 is 18. B times b is b squared, and c times c is c squared. So the LCM is 18b squared c squared, and this is the LCM of 9b squared c and 6bc squared. Now let's consider this example. Let's say we have x plus 3 in one bracket, and we have x minus 2 in another bracket. Feel free to pause and try out this example by yourself. So in this case, like the previous examples, we're going to start by drawing a table when we write the figures inside the table. Here we'll have x plus 3, and here we'll have x minus 2. So now, how are we going to divide? Do we first divide by x, or 3, or 2? Well, what we do here is we divide by the whole, like everything in the bracket, because x plus 3, it can't be divided by let's say number like 2, because x plus 3 is like separate terms. They are separate. So if we had something like x times 3, in this case, if we are to divide, let's say by x, we can divide, then x will cancel out x. But since we have x plus 3, they won't combine, unlike x times 3. So therefore, the only way to reduce x plus 3 to 0 is by dividing by x plus 3 itself. So everything will cancel everything. So if we divide by x plus 3, it will cancel and we'll be left with 1 here. Now what of x minus 2? Does the x cancel x here, and do we bring down minus 2, or do we also divide by x minus 2? Well, what we'll do here is we'll divide by x minus 2. If x minus 2 is here, we'll divide by x minus 2. So everything will cancel everything here, and we'll be left with 1, and 1 also come down here. So since we have reduced both terms to 1, we can now multiply everything to get the LCM. So therefore, the LCM is equal to x plus 3 times, so this is in one bracket, x minus 2, also in one bracket. And if I multiply these two terms, I'll have the LCM to be x plus 3 in one bracket and x minus 2. And this is the LCM of x plus 3 and x minus 2. Now you can also choose to expand what we have here. If you don't understand what it means to expand, please, I recommend you watch my video on expansion. But normally in LCM, it's best if you leave your LCM in this form. Thanks for watching. Please don't forget to like and subscribe to this channel, and don't forget to hit the notification icon so you can be up to date with all my latest videos. And please remember that practice makes perfect in everything you do. And also, please don't forget to share this video to anyone you think might have problem with this particular topic, and don't forget to check out my other videos. Thanks for watching.